Welcome to Espresso on Electronics, quick sips of video wisdom. I'm your host Anika Sunda, and joining me today is Paula Matthias. Today we're going to discuss about a very interesting topic, which talks about the opportunities to leverage generative AI in formal verification. Paula is a principal product engineer at Cadence, and she's also a pioneer in applying generative AI to formal verification processes. Paula brings with herself a master's degree in data science, so today it's going to be quite exciting talking to Paula. Welcome to the show, Paula.
Thank you for having me, Anka. It's a pleasure to be here.
So, Paula, for our listeners who might not be familiar with formal verification, could you explain what it is and what is the significance in the tech world?
Sure. So formal verification is a technique that uses mathematical methods to check that an RTL is correct or not, given a specification, right? So maybe most of our listeners are more familiar with simulation, which relies on creating test benches to simulate the design's behavior under different input scenarios, right? Trying to catch bugs that way. But Formal instead creates a mathematical model of the circuit and uses algorithms to exhaustively check all possible behaviors of that model of the entire state space. And because it's exhaustive, it can potentially catch bugs that slip simulation and also allows catching those bugs earlier on in the verification process.
Thanks, Paula. So, Paula, you've given us a brief introduction about formal. So, how do you think generative AI comes into picture, right? I mean, what is its importance, and what do you feel is its role when the synergy between Gen AI and formal, right?
So, generative AI really allows us to be creative in our applications, right? And this is not just informal, but in many fields in our industry, right? So, informal, we see different possibilities. For example, we can focus on enhancing the design bring up process and setting up your flow in formal, which can be a bit daunting to start with, right? And this can be done, Gen AI can be used both under the hood and in terms of usability, improving usability to the user. We can also focus on improving the debug experience for users, right? Which is extremely important when you catch a bug and you want to fix it with as much information as you can. We can also work towards creating strategies that are based on data to enhance the formal proof, which is one of the areas in informal that suffer the most when the complexity of the RTL increases, as we constantly see in the industry, right? So there's really tons of possible applications of AI in formal. But if we think about this power, right, and the huge benefits that we can get out of applying formal to your design, it's really key that we keep thinking of ways to help new users adopt formal. And we see great potential to use Gen AI in this area, right? So Formal relies on SystemVerilog assertions, right, which are pretty much the translation of the spec, right, of the behaviors that you want to verify against your design. So we need those checkers to be created in Formal. However, the syntax of this language and writing this code, writing good and syntactically correct properties can be tough, right, because of the nuances of this language. So we also see great potential to use generative AI to help non-expert formal users, right? For example, RTL designers and junior verification engineers ramp up in the tool by assisting them to write these formal checkers.
This is really fascinating, Paula. So, could you share a small example of how this has been implemented? What is the benefit or the value add that engineers can see if it was a kind of shift left to them, right?
So, if we think about ways to implement this and how this is being, researched, so large language models have led to, a true breakthrough in the way that we process and generate language through machines, and they seem to be, a good fit to generate SVA code from natural language. We see also, a great number of LLMs available and reachable, right, in the market. However, we see that these foundation models, which are, pretty much these base huge models, can show low quality of results for tasks that are very domain specific, right? Which is the case for SVA generation. So, and this is because they haven't necessarily been exposed to, a considerable amount of data of this type during training, right? So their overall ability to generate language is remarkable, and they can reason about many tasks, but we still need to work towards improving the results for SVA generation, right? And for this, different strategies exist, either by further to training, right, a model, doing fine tuning on it, or using RAG together with prompt engineering. So RAG stands for Retrieval Augmented Generation, and it's a technique that's being widely used and researched, both in academia and the industry. And this can be done so you provide relevant examples that will ground the LLM in order to provide a better answer. So yeah, having a tool that can generate SVA from natural language in a reliable way with using any of these strategies, catching the user's intent with correct syntax is very powerful. And it can help new users ramp up in the tool faster, and also potentially requiring less help from experts, right? So freeing up their bandwidth in this process. And by doing this, we can shift left, this process, especially if we're talking about um, RTL designers, right? Enabling these users to explore their blocks with more confidence early on, and catching bugs in the beginning of the verification, and therefore streamlining the whole process. So the potential for this is, it's very good for formal wider adoption, which keeps growing, right? Because it's such an important and strong verification process. Right?
Absolutely, but nothing comes for free, right? So I'm sure there must be challenges, right, in applying Gen AI to formal. So what are the typical challenges that you are seeing, or you feel, that pose a hurdle?
Yeah, so that's a great question. I believe that one of the main challenges in developing artificial intelligence algorithms, this is not just for formal, right, but for many technology applications. It's really ensuring that the algorithms are robust, right, and that they perform well if we consider different use cases, different environments, right? So for verification, we're talking different types of users, different environments, different RTL types, different verification purposes, right? So we need to make sure that we create and leverage good data, right? Because the output of a data-driven application is really only as good as the data that it feeds on, right? And it's also very key that we define strong criteria for measuring success, which can often be a bit difficult with generative AI solutions. They can be somewhat a little bit more abstract, right? If we're talking about generating language, for example, right? Um, and also, I think that we need to make sure that we're using the right applications to solve the right problems, and understand where AI can truly give an impact, right? Because we still have different tools, different ways to solve problems, and we need to make sure that we're targeting AI for, the biggest potential that it has. And of course, we need to be very conscious of computational requirements, and also IP protection, right? Which is a great, which is a it's very important topic for us to be aware of when we are serving our customers to verify their IPs, right?
Absolutely, you're right. I mean, good food or nutrition, which is the data, is very important, right? I think that's the most key element that you mentioned. Also,
Exactly.
Paula, what about? I mean, what's next in this field, right? Where do you think that the things are heading in for Jasper, right?
So Jasper already has has machine learning enabled features, but we want more, right? Of course. So given the amazing potential that we see in generative AI, and the fact that we have these tools available, and they are rapidly being improved and researched on, I can say for certain that Jasper will evolve to having different Gen AI enabled features and applications, right? And always focusing, like I mentioned before, on where these can bring the most impact to our users, focusing on, improving productivity, their results, and overall user experience in the tool, right? We want to make sure that we develop robust applications that are also adaptable to different AI setups, right, in our users, which we need to be aware of as well, and that can benefit from using user data, from leveraging user data to improve its performance, while of course always protecting it, right? And this will be executed in harmony with other great Cadence platforms like Jet AI and Verizum, right? So there's a lot of development and research going on in these areas, and I think we're going to deliver great products for our users.
Thank you, Paula. It's been actually incredibly insightful talking to you today. And thank you for sharing your expertise on leveraging AI in formal verification. It's been an absolute pleasure having you on the show.
Yeah, my pleasure. Likewise. Thank you for having me, Annika.
Keep your circuits connected and your ideas flowing until we meet next on Espresso in Electronics. Stay innovative.